The most recognizable haptic feedback that we can generate with our HAPTICORE encoders are ticks. But what makes a good tick? Is it soft or rough? And can I change tick characteristics? With the Customer Test app, we give you the perfect tool to customize your ticks so they fit your taste and your application. So hi, and welcome to another video about our HAPTICORE Customer Test app, in which we'll take a closer look at the different settings within the tick function and give you some important tips on how to create your own haptic feedback with ticks. As you may know, this video is part of a series about our HAPTICORE software solutions, so make sure to check out our channel and subscribe so you don't miss any announcements and new videos. But for now, let's start. Okay, so after we open the Customer Test app, we of course have to make sure that our HAPTICORE is connected and that we display all of our reports. After that, we activate the ticks in the Functions section and deactivate all other functions. Now we're ready to start, so let's head over to the tick settings. Without any parameters set, the tick function is set to a default mode. If you now test your HAPTICORE, you instantly feel the first ticks. However, the parameters of the mode vary depending on which HAPTICORE you use. To allow you to participate with any other HAPTICORE, we provide a document with the corresponding values for our other HAPTICORE encoders. Simply check out the video description to download the file. The first parameter you find here is the tick angle, where CW stands for clockwise, currently with 12 degrees. On the other side, you will find the counterpart with CCW, meaning counterclockwise, where at the moment the setting 0 deactivates the function so that the angle is the same as for clockwise. So you could also enter 12 degrees here and the haptic feedback would be identical. If we now want to increase the distance between the individual ticks, we have to increase the tick angle. So let's set a value of, for example, 15 degrees, and you could already feel the changed haptic feedback with a tick every time you cross the 15-degree angle. We can of course increase this angle further, for example with a value of 24 degrees, which we can then confirm by pressing the Enter key, and thus adjusting the feedback of the encoder. Now you feel a tick every 24 degrees, which however feels quite weak compared to the previous ticks with a 15-degree angle. This brings us to the next two parameters, the tick current and the tick velocity factor, which are responsible for the strength of the individual ticks. So let's take a look at the parameters, starting with the tick current. Therefore, we set the velocity factor to 0. The tick current is now responsible for the basic strength of the tick. This means that if we increase the value, for example, to 120 milliamps, we will feel much stronger feedback by turning the HAPTICORE. If we slightly reduce the value again to 60 milliamps, the strength of the ticks is reduced again when turning slowly. Why do we mention when turning the encoder slowly explicitly? Well, once you turn the encoder quicker, you'll notice that you almost feel no ticks at all, and that's where the tick velocity factor comes into play. The velocity factor allows us to increase the current that is applied to the coil, depending on the rotation velocity. So let's set the tick current to 0 to concentrate on the velocity factor. Here we put in 0.1. If we now turn the encoder, we will feel almost no haptic feedback when turning slowly. If we turn faster, however, we already feel light haptic feedback. If we increase this value further to, for example, 0.3, we feel slight ticks even when turning slowly and significantly stronger ticks when turning the HAPTICORE encoder quickly. So there is no one factor for the right tick strength here. It rather depends on the balance of the two values. However, we recommend setting the tick current and thus the basic force first, while the velocity factor is neutral. Of course, then the feedback is too weak while rotating fast. But then you slowly increase the speed-dependent strength using the velocity factor until you like the haptic feedback. Another interesting setting is the tick active direction. By default, this is set to both. This means that ticks are activated both clockwise and counterclockwise. If we want to change this for a specific use case, then we can, for example, activate the ticks exclusively clockwise, while they are deactivated counterclockwise. Of course, this also works the other way around by activating CCW. But for now, let's stick to both, as it brings us to the previously mentioned tick angle for counterclockwise or clockwise. Here we can now set the previously set 24 degrees for one direction, while we define our own value in the other direction, for example 10 degrees. If we now turn clockwise, which in our case using a HAPTICORE Mini means towards us, we feel a large distance between the individual ticks, while as soon as we turn the encoder counterclockwise, meaning away from us, we feel a finer tick grid. But there's not just one way to generate ticks, and as you may have noticed, we have skipped the tick mode function. Now that you know the basics about tick settings, let's take a closer look at these different tick modes. In general, our 4 tick modes differ in the way they apply current to the encoder coil, and thus generate unique haptic feedback. So far, we have used tick mode 4, which builds up the current around the tick in a sinus curve. The areas before and after the individual tick we call the tick window. You can also find this tick window as one of the settings in the customer test app. In tick mode 4, however, the box is deactivated, since the tick windows are automatically extended to the maximum possible space without overlapping the tick window of the next tick. This is ideal for getting started because you mainly configure the haptic feedback functions you already know: the tick angle, the tick current, and the velocity factor. If we now switch to tick mode 3, we gain access to this tick window field, because it is no longer automatically maximized, but instead can be individually adjusted. If we now enter 10 degrees in the tick window, the haptic feedback is quite similar to tick mode 4. However, if we now reduce the tick window, for example to 4 degrees, we get shorter ticks and a zone between the ticks in which no current is applied to the coil, as you can also see in the displayed diagram. And the smaller the tick window, the larger these no current zones between the ticks are. You can't just feel but even see this while turning the HAPTICORE encoder. Let's now set the tick window to 8 degrees and move on to tick mode 2. Even though the available setting options with the tick mode 2 remain the same, the current pattern that is applied to the coil changes in the background, and with it the haptic feedback you feel. After tick mode 3 and 4 generate a sinus curve, the tick current in tick mode 2 jumps and drops abruptly. So instead of a curve, it is more of a rectangular shape. If you now turn your encoder, you will immediately notice how the haptic feedback changes. The tick window, however, works the same as in the previously demonstrated tick mode 3 and widens or narrows the range in which the current is applied to the coil. Finally, let's take a look at tick mode 1, which offers you even more setting options, but is also fundamentally different from the other modes. This is because tick mode 1 generates ticks based on a function of time and angle. This means that our tick current is not centered around the individual ticks, but applied for a defined tick duration min and max. If we look at the figure again, the rectangle is not centered over the defined tick angle, but instead the current is applied for a certain time when the edge of the tick window is reached. However, to create natural haptic feedback using tick mode 1, we need a higher current, which is why we increase the tick current from 90 to 200 milliamps. Newly added are the tick duration min and max fields. These are related to the rotation velocity and define the time for which the current is applied to the coil. Slow rotation activates tick duration max, fast rotation activates tick duration min. We use these parameters mainly to generate speed adaptive modes to allow fast yet precise navigation through complex HMIs. But let's try this out with an example. For this, we enter a negative velocity factor, which means that the tick force is not increased, but instead reduced during fast rotation. We leave tick duration min and max the same and define 1 degree for the tick window. This means that with the tick mode 1, the current will be triggered at 23 degrees, 1 degree before the set tick angle when the tick window is reached. And now, when we turn our encoder slowly, we feel clear haptic feedback due to the tick duration max and our higher tick current. As soon as we turn the encoder faster, the tick duration min is triggered, and thus the negative velocity factor, which makes the ticks weaker. This allows us, for example, to move quickly through long menus and then make a precise selection by slowly turning the encoder. We should now, of course, save our new modes. If we now switch back to another tick mode, for example tick mode 2, you remember the current is no longer time dependent, but is built up in a rectangular shape over the center of the tick, then we have to lower the tick current again. For the next example, we also enter a positive value for the velocity vector and increase the tick window to 9 degrees. And with just a few clicks, we have a completely different haptic feedback, which we now also save as a new custom feedback pattern. And that's it. Now you know how to quickly create different ticks with a customer test app. Things went a bit too fast for you to remember all the tick modes on the first try? No problem. Simply test the tick functions yourself, and if necessary, rewind the tutorial. A description of all functions can also be found in the software documentation in your download folder. In the next video, we will continue with other haptic functions, so you learn how to create more complex haptic feedback patterns step by step. If you have any questions about our software solutions or our HAPTICORE products and Eval Kits, get in touch with us. But for now, leave us a like and subscribe to our channel so you don't miss any announcements and new videos. Have fun trying out our HAPTICORE technology and see you in the next video.